All right, so point estimation. What's the meaning of point estimation? Given a parameter of interest, like the population mean, the objective of point estimation is to use a sample to compute the number that represent, in some sense, a good guess of that true value of the parameter. So we would like to guess in this example, we have the point estimation for the mean. The resulting number is called a point estimate. So we can say that a point estimate of a parameter theta, it could be the mean, for example, is a number that can be regarded as a sensible value of theta, a reasonable value of theta. We have the estimate and we have the estimator. A point estimator of theta is a suitable statistics applied on a given sample data. So we have to use the estimator to get the estimate. Things would become clearer with an example. We need to estimate the true average of a battery lifetime. Let's say we have a factory that produces batteries and we are looking at the average lifetime. So the average lifetime of the population is mu, but we are picking a random sample of only 3, n equal to 3 batteries, with values in hours equal to 5, 6.4, 5.9, and they are selected as samples. So what's our point estimator? The estimator of mu, of the mean, is theta hat equal to the following. We sum all the numbers and we divide by the number of batteries, and that will give us an estimate of theta. Of course, it is not exact, it's an estimate, and this is why we use hat. It's an estimate because we don't have the full population. So we have, this is a random variable because we could select different batteries. The estimate itself for this example, if you substitute in the estimator, x bar, okay, equals to our estimate of the mean is 1/3, and we sum all the values, and that would give us in this case 5.77. Note that our estimate is not necessarily the exact true value of the population mean. It's going to be the it plus some error. So the characteristics of good point estimation or estimators, we have the first one, the estimators need to be unbiased estimator, which means the estimator on the expectation should give you what you are looking for. So basically here we are trying to estimate theta. There are two estimators, theta 2 and theta 1. Notice that if you use theta 2, your average value is coinciding with the true parameter to be estimated. So this is unbiased. However, for theta 1, there is a bias, and this bias is equal to the difference between what you estimate and the true value. Out of all these unbiased estimators, the best estimator is the one that has minimum variance. So we have MVUE, minimum variance unbiased estimator. So it's not just unbiased, it's also minimum variance MVUE estimator, or MVUE to stand for estimator. Among all estimators of parameter theta, that's the unbiased ones, select the one with the minimum variance. So we can have unbiased and not just unbiased at the same time having a minimum variance. A minimum variance will be like theta 1 here is minimum variance around, so it will give you the exact value faster compared with the other theta 2. A random sample x1, x2, xn from a uniform distribution on 0 to theta. So we have uniform samples between 0 and theta, and our job is to estimate this maximum value. So we're picking samples x1, x2, x3, and we don't want the average, we want to find the maximum. So those are two possible estimators which are unbiased. One concept, for example, is to pick the maximum value out of what you select and then scale it. Another one is to find the average and multiply by 2. So we can find here that the variance of this estimator is less than the second variance. We would like to pick the one which has less variance. So the variance of theta 1 is less than the variance of theta 2. So a good estimator is unbiased and have minimum variance at the same time.